First of all, would like to explain our number system, decimal number system, and it has digits from 0 to 9. So those are the unique symbols in this number system. We have digits from 0 to 9, and the range of this is 0 to base minus 1. What is the base? Base is 10. That is called decimal. Sometimes this is called denary. Decimal. So base is 10. 0 to base minus 1. Base means 10. 10 minus 1 is 9. 0 to. Okay, then, so the least significant digit is there in the right side, and the most significant digit, MSD, most significant digit is there in the left side. So, or we can call rightmost digit and the leftmost digit. Least significant digit, most significant digit, or rightmost digit and leftmost digit. So let's say, let's take example 7823.324. 7 is the most significant and 4 is the least significant. Or 7 is the leftmost and 4 is the rightmost. Okay, the positional values from the decimal point, it is increasing 1, then 10 times of 1 is 10, 10 times of 10 is 100, 10 times of 100 is 1000. Or we can call 10 to the power 0, 10 to the power 1, 2, 3. Likewise, positive value is increasing the left side when you go to the left side. And when you go to right side, the positive value is decreasing. After the decimal point, it start in the negative value, which is 10 to the power minus 1. We can call 1 divided by 10, which is equal to 0.1. 10 to the power minus 2, 1 divided by 100, which is 0.01, and 10 to the power minus 3, 1 divided by 1000, which is equivalent to 0.001. Okay, this part actually you have to write in the book. So what do you prefer, writing now or writing later?
Later.
This is basic, no? This is basic, so better write it now, I think so. You need this in calculations. That's why you need this in calculations. This is the basic. No? In anyway, lesson should have the foundation. After that, you can skip and write it later. But foundation better right now. So can you write the same? Okay, I'll give you this as exercise. Decimal number. Can you write the same for octal, binary, octal, hexadecimal, all three together? Or you can divide the page into 4 sections, right? Decimal,
Okay, sir.
Binary, octal, hexadecimal. So then write base. Base is 10 in decimal. In binary, base is 2. In octal, base is 8. In hexadecimal, base is 16. One table. Digits. These are the digits in decimal. So what are the digits in binary? What are the digits in octal? What are the digits in hexa? What is the range? An example. And this MSD and LSD with the positional values. So just complete a single table, single large table, this direction. Okay, I'll give you 3 minutes. So just as a table, write this, and there are 5 columns. The first one is number system. The second indicate the base. Third is digits. And fourth is range. And the fifth is example. Sixth is positional values. That's all. Number system, so you can say decimal. So base is 10. Number system binary. And base is 2. So number system is octal, and base is 8, and number system is hexadecimal, and base is 16. So now complete the tables. That's what I asked. So no need to write everything here. So just complete the table for number systems. You can do, this is a sample table. From the answers that you have written, so can you tell me what are the digits?
Digits for decimal 0 to 9.
0, 1, 2.
2, 3, 4, 5, 6, 7, 8, 9. Yes.
And for binary, it's a
0, 1.
and
0,
octal
1.
it is
0, 1, 2, 3, 4, 5, 6, 7.
and for hexadecimal, it's a
0,
decimal.
1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F.
So why these ABCDs are used?
10, 11, 12, 13, 14, 15.
So why this ABCD is used? Yes, why you can't use 10?
Because the same thing is repeating, right? Like
Yeah.
yeah.
If you write
So
10, so you can see 1 and 0. Again,
Yeah,
they are in
it
this
is.
10. So it should be unique symbol. This is not unique symbol. Therefore, in order to replace the 10, but value is still the same, A is used. A, B, C, D, E, and F are used. Only up to F, right? Because F value is 15. After 15, you don't have value because so hexadecimal is going up to 15. So it's always so 0 to base minus 1. So that is same for everything. Base is 10, it is 9. Base is 2, it's 2, 1. If base is 8, it is 7. If base is 16, it's 15. That is common for everything. And example. So you can write any example.
90.
Even this is correct, right? Some people think this is wrong. This is also correct.
Yeah. Yes.
Because 1, 0 are acceptable. Right? You have to write here, you have to write the base properly. Right? Base need to be written properly. Otherwise, it's wrong. If you write the base properly.
So range, it's not 0 to 9, 0 to 1, 0 to 7, and 0 to 6.
Yeah, that can also be answered. That is also okay. So equal, this is equal to 0 to 9. So anyway, answer for this one is 0 to 9. For this one, it is 0 to 1. This one it is. You can write both if you want. 0 to 7. And this is, it is 0 to 50. Which means A. Sorry, F. Examples. So this example can be written for everyone. Binary also this is correct. This octal also this is correct. Hexadecimal also this is correct. Only thing is the base is changing. Because sometimes you get confused. Because when you see a number like this, without looking at the base, you think, this is a binary. This is no. That can be binary, octal, that can be hexa, anything. Because 1 and 0 possible in all the number systems. So therefore, you can write like this. So this example is common for every number system. 1, 0 supported in every number system. And then the positional values actually you have to tell a few. So let's say, so I'm going to copy this from this table. This is how positional values are distributed. Okay, first one you can see. So it is base 10, and the second one also you can write. Third one and fourth one. Right. So don't write like too much of values. This has become confusing now. Okay, I'll use normal without table. I'll write. So 2 to the power So the positional value will be changed like 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0, 2 to the power minus 1, 2 to the power minus 2. Likewise, it's changing. This is the power. The power part. Minus 1, minus 2, and this is how it's changing. Let's make this smaller. Seems too small now. Right, anyway. Okay, what are the values? Values basically it is 2 to the power 3 is 8, then 2 to the power 2 to the power 2 is 4, then it's 2, it's 1, and then it's
0. 1.
1. 2 to the power 0 is 1, 2 to the power minus 1 is 0.5, and the next one is
minus
0.25.
also coming.
Sorry?
Minus is also coming in this.
Yeah, so better write minus powers because so after decimals you have minus, no?
Okay.
After decimals you have minus. Two to the power 3 is 8, then 2 is 4, 2 to the power 1 is 2, 2 to the power 0 is 1, and then you have 0.5. And this is how values are changing. 0.25. Make more room to this. Okay, you can see. And then the next is 8 to the power numbers. So you can write 8 to the power 1, 8 to the power 1, 8 to the power 0, 8 to the power 1, 8 to the power 0, 8 to the power minus 1, and 8 to the power minus 2. Here 8 to the power 3, 2, 8 to the power 3. So what are the values? What are the values? Yes. So any number to its power 0 is any number to its power 0 is 1. So any number to its power 0 is 1. This is 1. And 1 divided by 8 is 0.125. Yes. So then 1 divided by 64. I'm just going to write the value, right? 1 divided by 64, but I'm not going to write the decimal value. So this is 1 divided by 8. Otherwise it will be lengthier, right? That's why. And this one is 8 to the power 1 is 8, the same number. And 8 to the power 2 is 8 by 8 is 64. And 8 to the power 3 is 8 by 8 by 8. 64 by 8 is 512. Is it correct? Hello?
Yes, sir.
Is it correct? 8 to the power 3, is it 512?
Yeah, 8, 64, 64.
Yes, sir.
Yeah.
It's 512. Okay, I think you have completed this, right?
Yeah.
We did everything except the positional value.
Positional value.
So this
So for the examples, we didn't write like that. We put
examples.
just like then 10, then 11, then here over here we put 60, 6 and they are
I didn't get you. For example, you can write anything. I just gave the same example because this is.
we wrote for under decimal we wrote 10 and
Mm.
under binary we wrote 111, octal 67,
Mm.
hexadecimal 58.
Okay, there's no issue. You can write anything.
Okay.
No issue, but why I gave this, because some students are confused. They think that so 10 comes in binary only. That's why I gave this, because otherwise they will be trapped in the exam. By giving 10, you will think that this is a binary. Blindly you decide without seeing at the power, without seeing the base, you will decide this is a binary. No, it's not. So if it is base 2, then it's binary. If it is base 8, then that is octal. If it is base 16, then that is hexadecimal. If it is base 10, so likewise. Okay, base 16 also. Just tell me the values. 16 to the power 0. What is the value?
1.
16 to the power 0 is 1. 16 to the power 1
16.
is 16. 16 to the power 1 is 16. 1, 6. And what about 16 to the power 2?
6, 256.
Sorry?
256.
It is 16 by 16, which is 256. 256. What is 16 to the power 3?
409. 409. 4096.
4096, yeah. 16 to the power 3 is 16 by 16 by, that is 4096, 4096. And what is 16 to the power minus 1? 16 to the power minus 1 is 1 divided by 16.
1 divided by 16.
And 16 to the power 2 minus 2 is 1 divided by 256. Because 1 divided by 16 to the power 2, no, that is 256. Okay, so this is how it's going on, right? This is how the positional values are going on. Or maybe you can write the same for decimal, right? So after just by removing this table, you can just write the same for decimals. But decimals, there's a different way, basically, that is 10 to the power minus 2 is 1 divided by 100, and 10 to the power minus 1 is 1 divided by 10. Anyway, it's almost same pattern. 10 to the power 0 is 1, and 10 to the power 1 is 10, and 10 to the power 2 is 100, and 10 to the power 3 is 1000. So likewise, it's 10 times. 8 to the power numbers 8 times. 2 to the power numbers always 2 times. And then 10 to the power numbers 10 times. 16 to the power numbers, so base 16 number 16 times. So here it always divide by 10. When you go to right side, 1000 divided by 10, 100, 100 divided by 10, 10, 10 divided by 10, 1, 1 divided by 10, this, that 1 divided by 10 divided by 10 is 1 divided by 100. So this side it's multiplied. 10 times of this is this, 10 times of this is 1, 10 times of this is this, like this time, this is 10 times. Right, left side it is 10 times, right side it's dividing by 10. Here also, left side it is multiplying by 8, right side it is dividing by 8. Sorry, multiplying by 2, left side multiplying by 2, right side dividing by 2, because it's base 2. So the next one, base 8. So left side is multiplying by 8, right side is dividing by 8. Base 16, left side multiplying by 16, right side dividing by 16. That is the pattern of any number system. Now you know the basics. Having said that and having completed that activity, now you can move to the conversion part. Okay, let's see how conversion happens. Okay, so this is summary actually, right? This is a summary, and you can see, so just see the number system, how you convert from any number system to decimal. How you convert any number system to decimal. basically you take the positional value and add it. Right? Assume that this is a binary number and you take the positional value. This is 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 6. So what you have to do is you have to add these numbers. So add in here 2 to the power 1 is 1, then 2, then 4, then 8, then 16, 32, 64, 1 to 8. Add in all these things will give 255 as the answer. Right, and this one you have to add 1 plus no 2s, 4 plus 1 plus 4 plus no 8, 16 plus 32 is 64 is also not there. 1 to 8 are there. Then 1 to 8 plus 16 plus 4 plus 1 is 149. That is how you convert from any number system to decimal number. Right, okay. So let's learn that by doing small exercise. So please write down as a question, convert the following numbers to decimal. Convert the following numbers to decimal. The first one is the binary number. The second one, so let's do 4. The second one is octal number. The third one is hexadecimal number. Okay, 3 will be enough. Okay, try to convert the following numbers to decimal numbers. If you need assistance, please let me know, then I can help. I think so in the A-level examination, for each of these kind of thing, you have to take only 1 minute, right? In the A-level
For each question, right?
Yeah. For each question, you have to take 1 minute. So why?
Okay.
Because so if you slow down, that will slow down the entire paper. So try to follow that protocol and try to do this within 3 minutes. Here we have 3 numbers. Try to do it within 3 minutes. Now we can start.
Okay.